everyone! A pleasant day, parents, teachers, and learners. Welcome to Project SOAR, series of online academic review of mathematics guide learning modules. I am Mrs. Nadja Ollos from City of Mandaluyong Science High School, and I will be your reviewer for week 1 of grade 11 math. Let's start. For week 1, we have discussed the circle and its equation in standard form. So previously, in our discussion, we have said that the equation of a circle in standard form is given by the square of x minus h and the square of y minus k equals r squared. Before we talk about the different problems that we had in our module, let us remember Polya's problem-solving process. According to Polya, step 1 is to understand the problem. Step 2 is to devise a plan or translate. Step 3 is to carry out the plan or solve. And the most important of them all is step 4, which is to look back and double-check our final answer. If it doesn't work, then we have to go back to step 2 and devise plan B until we are able to solve our problem successfully. Let's begin. Our example is taken from Let's Practice. Example number 1, A, B, and C. In this given, we are to identify the coordinates of the center and the radius of each of the following circles. Let us go through each example one by one. For the first example, we have the square of x and the square of y is equal to 36. And the first thing that we must do is to devise our plan. Since we already understood that we are looking for the coordinates of the center and the radius, we must now devise our plan. The first plan that we should do is to identify whether the given is in the form the square of x minus h and the square of y minus k equals r squared, which is our standard form. And obviously, in this given, it is not yet in the standard form. So what we'll do is to manipulate our equation in such a way that we will be able to obtain the standard form. So we must rewrite the left-hand side of our equation to get the given format. So we can rewrite the square of x as the square of x minus 0 since we are not violating anything. And this value is still the same as x squared. Same goes for y squared. We can rewrite it as the square of y minus 0 and it's still the same value as y squared. Hence, the standard form of this given is the square of x minus 0 and the square of y minus 0 equals 6 squared for r squared. And since we know that the coordinates of the center are h and k, therefore, our center in this given is 0, 0, and our radius is equal to 6. Next given. So we have here the square of x minus 2 and the square of y plus 3 equals 25. Like how we did it for letter A, we must check if this given is already in the standard form for us to easily identify our center and our radius. So the first part of our given in letter B is already in the form the square of x minus h. While the second part of the left-hand side of our equation, or the second expression on the left-hand side of our equation, is not yet in the form the square of y minus k. So that means we must rewrite it as the square of y minus negative 3 so that it is already in the form the square of y minus k to easily identify the value of k. Hence, the standard form of this given is the square of x minus 2 and the square of y minus negative 3 equals 5 squared. And therefore, our center is 2, -3, and our radius is 5. Lastly, letter C, we have the given the square of x and 1/2 and the square of y minus 49 is equal to 0. I noticed that there is a constant on the left-hand side of my equation, wherein the standard form has no constant on the left-hand side of its equation. So that tells me that I need to eliminate my constant here by, by adding the zero pair. So if I add 49 here, I must also add 49 on the other side of my equation to make it balance. So after doing this, I have eliminated the constant on the left-hand side of my equation. This part is familiar to us, and this is example B. So we already know how to manipulate it. Y squared is similar to example A. So we also know how to manipulate it already. So we will have the square of x minus -1/2 and the square of y minus 0 equals 7 squared. And therefore, our center for this given is -1/2, 0, and our radius is 7. The next item is taken from post-test number 3. We are to determine the center and the radius of circle 2x squared plus 2y squared equals 5. If you can see the given, it is very familiar with example 1a. It's just that the left-hand side of our equation has a numerical coefficient of 2. But we can manipulate it so that we can get the same given as example 1a. The first thing that we must do is to factorize the greatest common factor 2. So we will have two groups of square of x and square of y equals 5. To fully isolate the expression in the parentheses, we divide both sides by 2. Hence, we will have the square of x and the square of y equals 5/2. And from example 1a, we already know that the center on this kind of problem is 0, 0. And for the radius, we have r squared equals 5/2. So if we are to get the square root of r squared and the square root of 5/2, we will have the square root of 10 over 2. Therefore, our final answer here is that the center is 0, 0, and the radius is the square root of 10 over 2. Let's proceed. The next items are taken from Test Yourself. For this item, I will be using GeoGebra to show you the figures. To better visualize the problem, I am using this graphing software, GeoGebra. The problem says, find the equation of a circle with diameter AB, where the coordinates A and B are 4, -3, and 2, 1 respectively. Let me plot the points first. So I have point A at 4, -3, and point B at 2, 1. And these points make the diameter of the given circle. Now, the next thing that I will do is to identify the values that I need to get the equation of this circle in standard form. And since it's the standard form, I will be needing the center with coordinates hk and the value of the radius. Now I have to identify the relationship of these values with my diameter since I only have the diameter as the given. So from this diameter, I need to get the values of the center, the coordinates rather of my center, and the value of my radius. For the center, since we all know that it's the middlemost point of the circle or the midpoint of the circle, therefore, to get the coordinates of the center, I can simply get the average of the x coordinates and the average of the y coordinates. So if we will get the average of the x coordinate, that is also the same value as the h coordinate for the center. So we will have here 4 plus 2 divided by 2, which is 3 for the x coordinate or the value of h, and for k, or the y coordinate, which is the average of the y coordinates of a and b, which is negative 3 and 1, divided by 2 equals negative 1. I will have 3 and negative 1 as the value of the h and the k coordinates. And if you plot the center on this graph, you will clearly see that it's 3, negative 1. So therefore, my center for this given is 3, negative 1. Now for the value of the radius, like how we did it for the center, we must identify the relationship of the radius and the diameter. And we all know that the radius is half the length of the diameter. So that means if I know the length of my diameter AB, I just simply divide it by 2, and that's my radius. Using the distance formula, I'll be able to obtain the value of AB and divide it by 2 to get the radius. And since I also have the coordinates of my center, I can also use distance formula to get the value of the radius from the center to any point on my circle. So I can get it from the center to point A or from the center to point B. Another method is by using the concept of right-angled triangle. If I use my right-angled triangle here, the radius now serves as the hypotenuse of this right-angled triangle. And since I know how to get the hypotenuse of a right-angled triangle using Pythagorean theorem, then that is also possible. I'm choosing this method because I can easily count the number of units for my two legs. So for this side, I have 2, and for this side, I have 1. So by substitution, to get the radius or the hypotenuse, we will have the square root of 2 squared and 1 squared, which is equal to the square root of 5. Therefore, my radius in this circle is square root of 5. Now I already have the values I need to get the standard form of the equation of the circle. So I need to plug them in the standard form. So we will have the square of x minus 3 and the square of y minus negative 1, or the square of y plus 1 equals the square of the square of the square root of 5. So by simplifying this given, the standard form of the equation of this circle is the square of x minus 3 and the square of y plus 1 equals 5. And this is the final answer. For example number 2, we have find the equation of a circle which touches the x-axis and whose center is negative 3, 5. So again, let us plot the given that we have. So according to the problem, the center of our circle is at negative 3, 5. And another information from the problem is that it touches the x-axis. This is the entire x-axis. So where could the other point be if it touches the x-axis? Let's try to draw the graph of the circle and see where it will touch the x-axis. So as you can see from the given, it touches point negative 3, 0. So that means we have the center at negative 3, 5, and it touches the x-axis at negative 3, 0. So like how we solved number 1, we need to identify the values that we have to have for us to solve the standard form of the equation of this circle. So we already have the value of the center, or the coordinates rather, of the center, which is negative 3, 5. We just need to figure out our radius. Previously, we mentioned that the radius is the distance from the center to any point on the circle. So since we already have our center and another point on the circle, we can simply count the number of units between point A and point B, and that is our radius. So we have here 1, 2, 3, 4, 5 units. So our radius here is 5. From point A to point B. After getting these values, again, we just need to plug it in our standard form, and that's already the equation of our circle. So we will have the square of x minus negative 3, which is the square of x plus 3, and the square of y minus 5 equals r squared. So we just need to simplify it. For our final answer, we'll have the square of x plus 3 and the square of y minus 5 equals 25. And this is the equation of this circle in standard form. Let me now go back to my presentation. Now we have the circle and its equation in general form. So we are done with standard form. Let us add general form. So according to the general form of the equation of a circle, it is given by the square of x and the square of y plus 2gx plus 2fy plus c equals 0, where g squared and f squared minus c is greater than 0, such that negative g, negative f is the center, and the square root of g squared plus f squared minus c is the radius. So basically, the general form is simply the expanded form of the standard form of the equation of the circle and equated to 0. So you can get it if you have the standard form. just expand it and equate it to 0, and that's already your general form. Let's try an example. So given this problem, we are to find the center and the radius of the circle. So method 1 is by identifying, like how we did it for standard form, we identify if the given is already in the general form. So check if the given is in the form x squared plus y squared plus 2gx plus 2fy plus c equals 0. And as you notice, it is not yet in the given format. So like how we did it from the previous examples, we again manipulate our equation by dividing everything by 2 and equating it to 0, since that's our general form. So if we do that, we will have the square of x and the square of y minus 3 halves x plus 2y plus 1 half equals 0. After this, according to the general form, 2g is given by negative 3 halves. Therefore, g is negative 3/4. And 2f is given by 2, where f is equal to 1. So for us to find the center, according to the general form, the center is given by negative g, comma negative f. So since we already have the value of g and f and c, we can now get the center, which is negative g, comma negative f. And that's equal to 3/4 and negative 1 for our center. For the radius, it's already given by the form the square root of g squared plus f squared minus c, wherein the values of g, f, and c are already provided. So upon substitution, the value of the radius in this given problem is the square root of 17 over 4. We can also solve the same problem and find the center and the radius of this given circle using completing the square. That's our method 2. So the first thing again that we will do here is to check if our given is in its general form. So if not, we again manipulate the given to get the general form. So in completing the square, our goal here is to be able to translate this general form that we have here into its standard form. Because in its standard form, we can clearly see the center and the radius. And for us to get that, we will be using completing the square. So the first thing that we'll do is to group all the terms with variable x on one side and group all the terms with variable y. To get the form, the square of x minus h and the square of y minus k for standard form. Using completing the square, we will have x squared minus 3 halves x plus negative 3/4 squared. And it's now a perfect square trinomial. And if we factorize this one, we will get the form square of x minus h. For the second one, we will have y squared plus 2y plus 1 squared. And now, it is already a perfect square trinomial. We can again factorize this one in the form square of y minus k. And since we have added negative 3/4 squared and 1 squared, we must subtract them to make the equation still balanced and equal to 0. So we will have The negative of negative 3/4 squared minus 1 squared plus 1/2 equals 0. So since we already know that we have perfect squares here, we can write them in their factored form. And we will have the square of x minus 3/4 plus the square of y plus 1 equals 17 all over 16. Comparing this to the standard form that we have previously learned, we can clearly see our center and our radius in the given. So therefore, our center here is 3/4 negative 1, and for our radius, we simply get the square root of 17 all over 16, which is equal to the square root of 17 all over 4, which is also the same answer as what we got for method 1. That will be all. Thank you. Thank you for listening. If you have questions, feel free to send a message to our official page, Math Team Mathematics Teachers of Mandaluyong, or send a message to your math teachers. Again, this is Mrs. Ollos saying, Math sayang mag-aral, tayo ng math tuto.